What do you expect from your selected Linux distribution? These can be aspects related to functionality or usability, or specific needs. There are about 30 widely used distributions, over 200 active ones, and more than 1,000 historically, each focused on a specific purpose. But what happens when you want to cover multiple aspects in your distribution? You will find that there is no single one that meets all your needs. Recently, I have evaluated more than 30 Linux distributions to show their performance evaluation and present this distro ranking. I would like to have a distribution that fits my needs. Can you imagine selecting components within a single distro? That would be a utopian task. For example, to reduce memory consumption using sysvinit or runit, or a minimal systemd configuration, as done by Anti-X and Raspberry Pi OS. Single-thread performance improves with minimal preemption, lightweight scheduling and caches, and aggressive governors, as in Lubuntu and Pop OS. Multithreading improves with better load balancing, more migrations, fewer penalties, and minimal daemons, as in Sparky and Peppermint. Memory read performance is increased with stable prefetching, efficient caching, fewer stalls, and better alignment, as in Debian and Gentoo. Write performance improves with higher dirty ratios, larger bursts, fewer fences, and aggressive writeback, as done by Kaki OS and Devuan. Everyone likes updates, but to avoid problems, a solid toolchain and good coordination are required, as in Arch Linux and Kali Debian testing. Browser memory use improves with better page sharing, lower RSS per tab, smaller heaps, and restrained caches, as in Zorin OS and Raspberry Pi OS. Packaging reduces disk usage. It must be extremely granular, remove unnecessary files, and apply aggressive stripping, as done by Gentoo and Fedora. Boot time is improved by not starting unnecessary services, with fast journaling, fewer rules, and no artificial sleeps, as in Arch Linux and Nix OS. Disk read efficiency comes from tuned read-ahead, no invalidations or polling, and a well-configured BFQ scheduler, as in Q4 OS and MX Linux. Regarding disk writes, a conservative writeback is important, avoiding fragmentation, again with BFQ and minimal read polling, as in MX Linux and Q4 OS. Finally, for threads and mutexes, a simple init helps. Although systemd could improve, a less fragmented scheduler as done by Void Linux and Alpine. Many of these aspects could be configured using an optimization script, but not all of them. That is why the perfect distribution remains a utopia. To find a solution, we need to talk. Comment, how can we improve our system? Could we help in any way? Not just a single distribution. See you soon.